Hi everyone, this is a tutorial for a GUI that calculates a steady state groundwater pressure and the flow pattern for given boundary conditions. This will utilize two separate files. The first file will be a boundary conditions file, which directly correlates to the second file, which would be for the actual head values. This GUI also has two separate panels. One is a user input, which has the user will input the K value, or the also known as the hydraulic conductivity, the transmissivity, and dx. dx represents the delta x, which is equal to this, which would be the same as the delta y, and it just represents pretty much the squares at which this whole all of this will be separated. I'll show you guys in a bit how that works. So we'll start with that first. Our first value, we'll set it to 2, transmissivity 2, and our delta x will be 50. In a bit, you'll see why we're utilizing 50. We load. Next, we're going to go into the analysis panel, where we first need to load our data. When loading data, it doesn't really matter where the file is at, as long as you're able to access it. For simplicity, I set the files under the MATLAB folder, under the documents. The first file that needs to be selected must be the boundary conditions file. So we'll upload that. And the second file that needs to be uploaded will be the actual head values file, which I labeled as boundary 2. Each of these files can actually be uploaded as text documents or in the format Excel format. Doesn't really matter. What's important is that these files, each of the values in these files is separated by a comma. I'll show you a little bit. I'll show you how these files look to clear things up a bit. So once those are uploaded, we can go down to command window, and here I'll go through and show you boundary heads for the first file set right here. Each of these -1s under the command, actually let me go back a bit. In the command window, once you upload your files, it'll give you the name of the file that's uploaded, the location. It'll give you the name of the second file, which is just labeled as file name 1 to differentiate from the original file. Idea here is that you have your first file is uploaded here, and your second file shows this name of the second file and its location. Once that's set up, it prints out the boundary heads for you, and it will show you how all this is set up. Now here, -1s, when building up your boundary heads file, -1s represent the top side of the whatever it is you're doing analysis on, and these would be constant values. These are values that will not be affected. So these are known pressure head values. And then anything with a 1, which in this case would be along the edges on the left hand side and the right hand side, and along the bottom, these ones represent no flow boundary conditions. So this means that there is no flow crossing into the boundaries, which pretty much creates a square with just flow conditions and no flow conditions. Anything in the middle is will have a 0, and it will be read as just an unknown value. The 2's in the boundary heads file represents an area where there's a well, and this represents water pumping in or pumping out of the system. That's pretty much it for the boundary heads file. Then on the second file that was uploaded, which is your actual head values, for this example we have values set at 100, 100.8, 101.6, so on and so forth. And then down here on the fifth row, third column, we have 2000, which represents the flow rate, and it correlates with that number 2. So this tells us that the number 2 tells us that there's a hole there, and there will be a flow rate going in or out of that area. And this value tells us what the flow rate is. So once we have these files set up, we can move on. But just before that, it's also important to note that your boundary heads and your actual head values, the matrices that are input must be equal. So if you have a 6, in this case we have a 6 by 6, our actual head values must also be a 6 by 6 matrix. So once we have that set up, we've uploaded our data, we have all of our user inputs. We click on the Analyze button and it will process information for us. This information, one second. With the window, we have a bar, a tools bar up top where we can upload, we can make different adjustments. So I selected the rotation tool, and here I'm able to rotate the printed file here. And as you can see, each of these deltas that I was talking about is from 50 by 50 by 50 by 50 by 50 along the XY direction, and that's what this 50 represents. Because this file was designed with the number 2 value, which tells us that there's a well in the system, we see where the well is at, and we see that because it's a negative, our Q over T value, which utilizes the flow rate over transmissivity value, is at this coordinate, and that tells us that that's where water flow will all be centralized. And that's what each of these arrows, velocity vectors, represents, the direction to which water or whatever fluid is flowing down will go into. So if we change the transmissivity to 1, we reanalyze data, we can actually reprint, and it will show us the updated drawing. One other thing we can do with this is add a legend, and we can take a look at some pinpoint numbers. We can pinpoint some numbers here, sorry. So this right here tells us that at negative 201 elevation, that's where that would be the location of that point. Tells us that our maximum is 104. And we can actually correlate these different z values that we see right here with the matrix that I'll show you in a bit. So during the process, all of this occurred in the background. We have the solved heads column vector, which is pretty much the solution to a generated matrix system. And this column vector is then converted into SH, pretty much stands for solved heads, converted into another 6 by 6 matrix with the solutions to the heads. And this SH represents these colored squares here. Then the QX and QY are the actual flow rate, or the components, the velocity vector components for these arrows that we see here, up top here, and these down here. So this just tells us again the direction of where the fluid is flowing, and for this particular setup, it all centralizes down here by where the well would be at and into the well. And that's what these QX and QY components are for. Because we ran this 2 or 3 times, we ran this 2 times, we were able to see it prints out the different values that changed with transmissivity. There isn't much more to this. It's a pretty standard, simple tool. Yeah, you can make some adjustments to the K value if you'd like. We'll cut this one in half. Analyze data. Doesn't seem to give us much on this. Switch transmissivity to 0.5. Should give us data. There you go. There you go. Again, we can see what's happening here. Oh, that's pretty much it. Any questions, you can leave a message down under. Thanks for watching.